Hello scientists, and welcome to the How to Collect Ball on Ramp data video. In this video, I'm going to show you how to collect the data in the ball on ramp investigation, which, as you might infer, involves rolling a ball down a ramp. Now, why are we doing this? Well, when you roll a ball down a ramp, it speeds up, it accelerates. By doing this, we will be able to determine a mathematical model that relates distance and time for an accelerating object. And that gives us more predictive power because now our models can involve acceleration, whereas before they only could involve moving at a constant velocity. Now, you are not the first person to do this. In fact, about 500 or so years ago, a dude named Galileo Galilei did the same type of experiment. And he was the first person to establish this relationship. And he did it in an era where clocks did not exist, so he had to time using drips of water. In addition, his work, there he is right there and right there, his work challenged orthodoxy, it challenged tradition, it challenged Aristotle, it challenged the Catholic Church. He was saying, if you use a scientific method, if you collect data from the world and build models with that data, then your information and your understanding of the world increases. It is better to do it that way. And he paid a price for that. The Inquisition tried him and accused him of heresy and put him under house arrest until he died. Not specifically for rolling balls down ramps, but for using science to challenge tradition. So if Galileo can do it, so can you. Okay. He was asking the same question you're going to be asking. What mathematical model describes the relationship between time and distance for an object that is accelerating? Now, here's a bunch of potential models showing the relationship between distance and time. As part of getting ready for this, you're going to complete your investigation handout, which involves identifying your variables and then making a hypothesis. Which one of these models do you think will represent the relationship between distance and time? Once you've got that done, then you're ready to collect data. And you will need these things. 1, polished and beautiful steel ball bearing. 2, little green Flynn timers. A stool. A ramp, which is just a piece of PVC pipe cut in half. And a couple of little storage bins, the tan ones, to prop up your ramp and keep it from sagging. Okay? You should also put a little piece of tape in between the ramp and the stool that keeps the ramp in place, so the back of the ramp is right at the back of the stool, and it stays that way throughout the investigation. So you're not changing the slope of the ramp during your investigation. Okay? Now, once you've got this, you're ready for your first set of data collection. And you're going to start with what's called the gentle slope. It's called a gentle slope because it's not too steep. As you can see, the ramp itself is on the footstool, or the footrest of the stool, and not the top. You only got 1 bin supporting your ramp to keep it from sagging, and you want to make sure that the 0 meter mark, which is written on the inside of this ramp, is at the stool end. Okay? At this point, you're ready to collect data. You want to set this up, though, on the floor, not on the table like this, because your tables aren't big enough, A, and B, I only did this so I could take a picture and show you. There's plenty of room around the edges of the classroom to set up these ramps. Okay? So when you're ready to collect data, you got your ramp set up, you want to look at the ramp and note that there are distances marked on the ramp. Okay? This is a top-down view. You can see it's marks at 0 meters, 0.75 meters, 1.5 meters, 2.25 meters, and 3 meters. Okay? We're going to measure the time it takes the ball bearing to roll from 0 to each of these different distances. All right? And you will do it like this. One of you will be in charge of releasing the ball at 0 meters and letting it roll down the ramp. 2 of you will be timing. If you got 4 people in your group, your 4th person is responsible for not letting the ball bearing escape into the classroom when it gets to the bottom of the ramp, and you can take turns with the roller doing that. Here's how it goes. The person rolling the ball says 3, 2, 1, go, and she lets the ball go. At that same point, when she says go, the timers start their timers, and when the ball reaches 0.75 meters, they stop it. Now you have 2 people timing, so that's going to give you 2 times showing how long it takes the ball to get from 0 to 0.75 meters. All right. Then you roll it again to get a total of 4 trials, and then repeat from 0 to 1.5, 0 to 2.5, and 0 to 3 meters, giving you a total of 4 time measurements for each distance. Now, as you're doing this, you need to be careful. If you are measuring and the difference between 2 times you take for a single roll is greater than 0.2 seconds, you need to repeat those trials. For example, if you measured 1.24 seconds and the second person measured 1.54 seconds for a single roll, that's 0.3 seconds difference. That's not just uncertainty. That means someone's not timing right. That is an error. You need to throw those trials out and do it again. If you got these 2 times the second time, those differences are only 0.1 seconds, so you can use those trials and move on to your next roll. All right. Once you got all your gentle slope data collected, you will move on to the steep slope, which is different in that the ramp is at the top of the stool. Still, the end of the ramp is at the back of the stool. In this case, you will need 2 bins to support it and keep the ramp from sagging. Note I've got them perpendicular to each other so they will stand up. Okay. This should allow you to collect both gentle slope and steep slope data for the ball on-ramp investigation. And unlike Galileo, you will not be put under house arrest for doing so. Okay, I hope this helps.